Hello, my name is Kemper Sutton. I'm a graduate student in the Department of Entomology at Virginia Tech. I'm co-advised by Dr. Tom Kuhar and Dr. Stephen Rideout. I've had the privilege of being at the Eastern Shore since 2018. I actually lived out of the shore during the summer of 2019, and due to COVID-19, I was moved back to campus. However, I still did research trials out on the shore for Edamame, so I'm going to give you guys a quick update on what we did in 2020. I've given Edamame talks at the Eastern Shore Ag Conference for the past 2 years, and this is the first time I'm doing it virtually. So I'm just going to quickly go over what exactly is edamame for people who maybe are listening to me for the first time. Basically, edamame is known as the vegetable soybean. It's actually the exact same plant as the soybeans we grow here in America, except that it's harvested when it's still green instead of when it turns brown like we see here in the United States. And in this figure on the bottom, there circled in the red is the stage at which we harvest edamame, which is the R6 growth stage. And that's pretty much the point right before that plant starts to kind of die off, when those beans have completely filled out but are still green. So this plant is harvested as a vegetable. Now, the reason this project's been kind of started is that the United States is having increasing demand for edamame in the United States. However, there's not a lot of producers growing it here, so we're actually importing upwards of 95% of our edamame from overseas, from countries like China and Taiwan, which is really concerning because the United States is actually the biggest producer of soybeans in the entire world. So there's really not any reason why we can't grow vegetable soybeans. So this grant is really looking at trying to get farmers or people in the Mid-Atlantic to be interested in growing this product domestically. Since 2018, we've had a couple different projects, one of which was to evaluate the different types of insects getting on vegetable soybeans or edamame. As you might expect, they're very similar to the conventional soybeans we grow here in the United States. However, there are some key differences that I'll get into, and basically we had three types of damage we kind of ended up having, three categories. The first being chewing, which is primarily done by the corn earworm, which is a very common agricultural pest. And the problem with that was that they're actually chewing through the pod of edamame, eating the bean inside, as you can see in the picture on the left. Then the middle was the most concerning type of damage, which is done by stink bugs primarily, and they have this piercing, sucking-like mouth part, which is essentially a straw, and they take that straw and can feed on the bean inside of the edamame pod. And so basically in this picture in the middle here is of the type of damage you might see from stink bugs. And that's very concerning. And what's the most concerning thing about that is if you were to close that pod right there, you wouldn't be able to see any of that damage from the exterior of that pod. Basically, you could walk into your field, all your beans look great, but little do you know that those stink bugs have fed on that bean and it looks like this on the inside. So it's a huge quality issue. Now, lastly on the right here is the defoliating pest. This is going to be mostly beetles, and they're going to be chewing on the leaves, and ultimately they're not really that big of an issue. Due to the fact that we're treating this crop as a vegetable, that cosmetic damage being created by stink bug feeding is actually our primary type of damage we're seeing, and it's very concerning. So for the sake of time, I'm really going to focus this presentation on stink bugs and the damage we're seeing. So in this slide here, I've got the three main types of stink bugs we're seeing. Starting on the far right, most of you may be familiar with this one. This is the invasive brown marmorated stink bug from Asia. This is the one that you primarily see in your house and attic during the wintertime where it's trying to find a place to stay over winter. And that can be a very serious pest of soybeans and edamame both, and we saw that quite a bit this past couple of years. Now on the middle slide there is our native green stink bug where both the adult and nymph can feed on the pods. And then lastly on the left there is the southern green stink bug, which is just starting to show up in the state of Virginia in the southeastern part of the state near Suffolk and the eastern shore. And what's really bad about this stink bug in particular is that it's never really shown up in high numbers before, but these past couple of years we've had really high densities, and once they get in your field, their population can really explode. So there's one experiment in particular that I want to share with you guys today, and this experiment kind of follows up those evaluations of different types of insects. So now that we know that stink bugs are one of the key most important pests of edamame, it's important to develop an integrated pest management program so that when we do have large-scale production of edamame in this state, farmers have a resource that they can fall back on to know when to spray and what to spray. And so this is kind of the first step in that direction of developing that program. So basically this IPM experiment was conducted in the Eastern Shore ARAC and Painter using Warrior 2 in 2020, which is a pyrethroid commonly used in soybeans. And we had three different treatments. The first was an untreated control, basically meaning that we didn't spray any insecticides throughout the entire growing season. And then the IPM treatment was we used currently available soybean thresholds developed for our conventional soybeans and use that threshold for edamame. And so basically when we crossed a certain number of stink bugs in that field, we sprayed Warrior 2. Now the last treatment, the conventional treatment, if we saw any type of stink bugs in that treatment, we would spray Warrior 2. So the conventional was receiving a higher number of sprays than the IPM. And then at the end of that growing season, we took yield and then we measured the number of pods that were damaged by stink bug feeding. I want to dive straight into the yield of 2020 on the Eastern Shore. This figure is important because we did spray at thresholds for soybeans, and as you can see here, between the control, which received no sprays, the conventional that received the most sprays, and the IPM was received, the fewest sprays, there really wasn't much difference in terms of the yield in grams that we saw in that field, which is really good news to know that, these stink bugs, even though they're present in these fields at very high numbers, they're not hurting the plants, to the extent where they're causing a yield loss or killing the plants. The really big issue is, are they causing issues with the pods or our marketable portion, which I'm going to get to next. So throughout the growing season of edamame in 2020 at the AREC, we counted the number of stink bugs in that field weekly from the planting until harvest. And so this line graph here, the blue, red, and green lines represent blue is the untreated control, the red's the IPM, and the green's the conventional. And then you see the red and green Wi-Fi symbols, and those represents the dates in which those treatments were sprayed. As you can see, the conventional was sprayed 5 times throughout the growing season, while the IPM was only sprayed 3 times, basically meaning that we only went over threshold 3 times throughout the growing season. And basically you can see a trend with that red line. Basically when we went over threshold, the IPM was sprayed and knocked those numbers back down again. And around September 26th there on the right hand side of the graph, we had a large spike of southern green stink bugs in that field. We sprayed and knocked them back down again to a very manageable number. So how do these numbers stack up with pods being damaged? So this is kind of the end goal here, where we looked at proportion pods with stink bug feeding marks. We took 50 pods from each treatment, and we had 4 reps. That's 200 pods per treatment at harvest, and we opened them up looking for stink bug feeding marks. And now we know that these stink bugs didn't have an effect on yield, but what we're concerned about is cosmetic damage due to that stink bug feeding, as I showed you in that previous picture that had all the ugly spots on it. So the conventional once again received 5, IPM received 3, and they had very comparable control measures. The conventional had somewhere around 7-8% of the pods had been fed on by stink bugs with 5 sprays, but the IPM only had 3 and had very comparable damage, which was around 10 or 11% of those pods. Now the control, once again, that didn't receive any sprays had upwards of 30%. So we know that sprays are going to be necessary to control stink bug feeding, but I think if we have proper scouting strategies that we can minimize the number of sprays and still have very similar control. The takeaway message from this research is that stink bugs are the biggest pest of edamame, not because they're affecting yield, but because of the cosmetic damage they're causing to pods, and that's a major concern. However, we do know that IPM strategies can work. We don't need to spray a ton of times to control stink bugs, but finding out the proper insecticides and when to spray is going to be a key component of that. So what's next? Well, besides what we used in this project, which was Warrior 2, there's a long list of insecticides that we can test and figure out what might work best for edamame. Anything from a pyrethroid or to more organic options based on the market you're trying to sell to. And the end goal is basically adding edamame to the Virginia Pest Management Guide so farmers have that resource to look at when they need to spray their crop. Just wanted to give a thank you to my advisors and colleagues for helping me with this project, and I look forward to any questions you have, so feel free to contact me either at my email or my phone number listed here on this slide, and I'll be more than happy to talk with you about edamame or anything else.